everyone. Welcome to section 2.4, which we're going to do super fun word problems. I know you guys love word problems. Okay, so these involve like coins and mixing things and motion, rate times time equals distance. So first of all, let's talk about coins. If you have a coin, let's say you have 2 quarters, right? We know that each quarter is worth 25 cents. So the total value of 2 coins, if they're quarters, would be 2 times 0.25, which is 50 cents, right? So that's one thing to think of. You can write down, if you have a total value of coins problem, you would put the number, the value of each, and then get the total number. So to solve coin word problems, we basically use that kind of chart, okay? We list the types, we write the value, write the number of each kind if possible, okay? We also need to make sure we identify what we're looking for, and that's our variable, okay? How do you know which one is going to be a variable? Because usually they talk about it in kind of they refer to it. And you'll see what I mean when we start doing some problems. Let's go ahead and do some here. We have Danny paid $15.75 for stamps. The number of 49-cent stamps was 5 less than 3 times the number of 35-cent stamps. How many 49-cent stamps and how many 35-cent stamps did Danny buy? Okay, so we have 2 types. We have 49-cent stamps, and then we have the 35-cent stamps. Now, we don't know which is which, right? But we do have this sentence here that says the number of 49-cent stamps was, it's another word of saying is, 5 less than 3 times something else, the number of 35-cent stamps. So if we let 35-cent stamps be X, 49-cent stamps would be 5 less than 3 times X, right? Now, obviously, the value, in this case, it's 49 cents. And then this one here, it's 35. So it's similar to coins in that way, in that we have the number value and the total value. So then to get the total value, we multiply across. So that would be 0.49 times 3x minus 5. And then this one would be 0.35x. And then together, it has to be 15.75 total, because that's the total that he paid for the stamps. So if we write this in a very cool equation form, okay, oh, what happened? Here we go. It would be 0.49 times 3x minus 5 plus 0.35x is equal to 15.75. And then by now, we should know that if we want to get rid of the decimals, we can. Or we can just go ahead and just work it through, straight through. Okay, we're going to do that. Let's try that. So let's, distributive property. Okay, so we have 0.49 times 3x. That's going to give us 1.47x. Then you have minus 5 times 0.49 gives you 2.45. Plus 0.35x is equal to 15.75. Like terms. Okay, so that's going to be 1.82x minus 2.45 is equal to 15.75. So let's go ahead and add to both sides. Okay, that cancels out here. 1.82x is equal to 18.2. So then divide. Okay, 1.82. And we get that x is equal to 10. And what does that represent? X represents the number of 35-cent stamps. So how many 49-cent stamps? We have to plug it into here. So to find the number of 49-cent stamps, we go 3 times 10 minus 5, 30 minus 5, and that's 25 of the other stamps. So 25 49-cent stamps, and then there's 10 35-cent stamps. Okay. So, yeah, 25 of 49 and then of, just to make sure that you guys are not confusing them. This is an of, by the way. That looks terrible. 25.49 stamps. Okay. All right, let's do another one. Whale watching ship has 40 paying passengers on board. The total revenue collected from tickets was $1,196. So you have full fare passengers paid $32 and reduced fare passengers paid $26. How many full fare passengers and how many reduced fare passengers were on the ship? Okay, so we have another ticket problem. Okay, let's see here. So we have two types of tickets. We have full fare and we have reduced fare. Okay, full fare pays $32. Reduced fare pays $26. Okay, 40 total. So if 40 is the total number of tickets, let's say like we have to let one be X and then the other one would be 40 minus X. That's because the total is 40. Okay, so it's kind of arbitrary. So we'll let this one be X and the other one is 40 minus X. And for those of you that are confused as to why, imagine you and your friend have $40. If you have $2, your friend has $38, right? If you have $5, your friend has $35. If you have $3, your friend has $37. If you have X dollars, your friend will have 40 minus X. Okay, so that's kind of how that goes. So let's multiply across. We get 32X, 26 times the quantity 40 minus X. And then the total was 1,196. Okay, so let's go ahead and write the equation. We have 32X plus 26 times 40 minus X, and that's equal to 1,196. Okay, so let's go ahead and solve. Let's distribute this here. We get 32X plus 1040 minus 26X is equal to 1196. Like terms here, 32 minus 26 is going to be 6x plus 1040 equals 1196. Subtract both sides by that 1040. And we get 6x is equal to 156. Divide both sides by 6. We get x is equal to 26. So there's 26 full fare tickets. So 26 full fare tickets. And then to figure out the reduced fare, we have to subtract it from 40 because the total has to be 40. So 40 minus 26 will give you 14. So there's 14 reduced fare tickets. And that's it for this problem. So this is the number of passengers. Yeah, it's the same thing. Number of passengers, or we would say full fare tickets, or we would write passengers. Sorry about that. Okay. Let's see here. Let's do another mixture problem. We have here Henning is mixing raisins and nuts to make 25 pounds of trail mix. Okay, so this one is actually a 3x3. I'll explain why. Because it's a mixture problem. So we have a couple of things going on. So raisins, there's nuts, and then together is a trail mix. Okay, together is going to be 25. So raisins cost $4.50 a pound, and nuts cost $8 a pound. If Henning wants his cost to be $6.60 a pound, how many pounds of raisins and how many pounds of nuts should he use? So if we let raisins be X by the same logic as before, since they're together, it's going to be 25 minus X for nuts, okay? And then total value, multiply across. 450X 8 times the quantity 25 minus X. And then here would be 25 pounds times 660. So that would be the total value here. So your equation would read 4.50X plus 8 times 25 minus X equals, and then 25 times 660, whatever that is. Okay, so let's go ahead and do the calculations. So you would get 4.5X plus 200 minus 8X is equal to 165. Combined like terms, we get negative 3.5X is plus 200 equals 165. Subtract both sides by 200. So we get negative 3.5X is equal to negative 35. So divide by negative 3.5. You get X is equal to positive 10. Great, so that's the number of raisins. How about nuts? So 10 pounds of raisins. 10 lbs raisins. And then raising, I don't know why I put raising. Okay, fine. Raisins. How do you spell that? And then nuts is 25 minus X. So 25 minus 10 is 15 pounds of nuts. Okay. All right. Let's do another. Jesse has $3.02 worth of pennies and nickels. So we have pennies and we have nickels. The number of nickels is 3 more than 8 times the number of pennies. So number of nickels is 3 more than 8 times something. That's going to be X. That's the number of pennies. Pennies is worth 0.01. Nickels is worth 0.05. So total value, multiply across times 8X plus 3. And then the total value is $3.02. So let's go ahead and write that as an equation. Sorry about that. A little distracted here. So then 0.01X plus 0.05 times 8X plus 3 is equal to $3.02. Did you guys get that? I'm assuming yes. Okay, so let's go ahead and solve this out. Distribution property, 0.01X plus 0.40X plus 15 cents is equal to 3.02. Like terms, people, 0.41X plus 0.15 is equal to $3.02 or 200ths, right? So minus 15 hundredths from both sides. We get, 0.41 or 41 hundredths X is equal to, and then 302 minus 0.15 is 287. So let's divide. And that comes out to 7. So X, 7. So there are 7 pennies. And then how many nickels? So nickels is going to be 8 times whatever X was, which was 7, plus 3. So that's going to be 56 plus 3. And then you have 59 nickels. Okay. All right. And then the last type of problem we want to do is uniform motion. So that just means we're going to be using rate times time is equal to distance. Okay. We need to figure out, first what's, the rate, how fast you're going. Time is for how long. And this is how far. So how fast, how long, and then how far. Okay, so if they ask, depends. You have to figure it out. Oh, sorry, I don't know what I just did. Okay, yeah. So we're going to start with a chart. Let's go ahead and do that. Wayne and Dennis like to ride the bike path from Riverside Park to the beach. Dennis's speed is 7 miles per hour faster than Wayne's speed. So it takes Wayne 2 hours to ride to the beach, while it takes Dennis 1.5 hours for the ride. find the speed of both bikers. Okay, so what's happening? You have Dennis and you have Wayne here. Okay, Dennis's speed is 7 miles per hour faster than Wayne's speed. So we can let that be X, or we can let that be R for the rate. Speed and rate is kind of, they're both talking about the same thing. But we can go ahead and say, let's X equal Wayne's rate. And Dennis's speed is going to be 7 miles per hour faster than Wayne, okay? And so it takes Wayne 2 hours to ride to the beach, while it takes Dennis 1.5 hours, okay? And so in this case, we're actually not going to use this square, because you have Dennis, you have Wayne, you know, and they're going to the same place. They're both going to Riverside Park, okay? So multiplying across, we get the an expression for the distance. So this right here, this represents this distance that Dennis went, okay? And then 2x, I'll use a different highlighter because colors are fun. So Dennis's distance, Wayne, sorry, is the same. Do you notice they went the same distance? So what are we going to do in this case? We're going to equal them to each other. We're going to set them equal to one another, because they're not giving us a total distance, okay? So we're just, setting them equal to each other. So let's go ahead and solve this. We have 1.5x plus 10.5, that's equal to 2x. Okay, subtract both sides by 1.5. X, we get here 10.5 is equal to 0.5x. Divide by 0.5 both sides. And we get x is equal to 21. So what does that mean? That means that Wayne is going 21 miles per hour. So if Wayne is going 21 miles per hour, how fast is Dennis going? Well, what did we say Dennis was? We said here that Dennis's speed is 7 miles per hour faster than Wayne. So we just add 7, 28 miles per hour. And that's it, okay? Not too bad, right? Not too terrible. We're almost done. Let's do another example. Actually, hold on a second. Or I'll start on the next video.